Hello friends, welcome to the channel. In this video, we are going to learn what is Git from a manual testing perspective and how it is relevant to a ETL testing project. So we'll learn what is Git, what problem Git solves, why to use Git, Git CLI, command line interfaces, and Git as your collaborating partner. So let's tackle this question. What is Git? Git is a powerful tool for tracking changes in code and collaborating with other developers or testers. What exactly this tracking means? Tracking means if in a central repository you are making some changes and other collaborator making some changes, when all the codes gets merged, you can go and track the history, who changed what. So that is exactly called tracking. Now, what problems Git solves? Git prevents overwriting each other's work or losing code versions, which simplifies team collaboration. So that means if there is another collaborator and you both are trying to make some changes to a file or more than one files in a repository, if there is no Git, there are chances you overwrite each other's code. But when Git comes, it allows you to maintain your changes as well as the collaborator changes. And once you both merge, you have a single version of that file, but you can go and track who changed what. Why use Git? Git enables seamless collaboration, precise version control, and safe experimentation. For example, you want to experiment some of your data file, whether it's a JSON data, CSV data, or some other text-based data. You want to make some changes and you want to apply that in a system and see how the system behaves. You can do that by taking a branch out of Git and make your changes and do the testing safely without disturbing other developer or the tester. That is why we use Git. CLI, command line interface. Why it is so important? As a manual tester, you must know the basic CLI commands Git provides. So you can seamlessly work with GitHub, Bitbucket, or GitLab. Git as your collaboration partner. Git ensures a clear history and easy teamwork, making development smoother. Also nowadays, with the evolve of agentic AI capability of GitHub and other Git-based repositories, Git becomes a truly collaborative partner where it takes your instructions and does the job behind the scene and gives you the new version of the repository. So that is where Git becomes your collaboration partner, and you must know Git, how Git works, why Git is used. In our earlier slides, we covered how Git prevents you overwriting each other's work, how Git allows you not to lose your previous versions of the code, how Git solves the difficulties we face in a collaborative central repository without Git. So Git solves that problem. And we also saw why you use Git. Collaborative, you have a version control, you have a branching strategy, and it maintains history. Okay. Now next one, we'll know what is basic Git workflows. Okay. Understanding the fundamental steps of using Git for version control. First thing is, when you approach a code base, a development code base or a test code base, you have to clone the repository to your local computer, whether it's a laptop, desktop, or wherever you are doing your coding or testing. That's where you have to clone. That part is called clone. Cloning a repository, cloning a remote repository to a local repository. Then second one is make changes. Suppose you have a code file, Python file or a Java file or a JavaScript file or a simply data file, for example a JSON or a CSV file. You want to do some edit, you want to add something or delete some text in your local repository. You do all this in your local repository without disturbing the remote. Then you stage your changes. That means after you make the changes, make sure you give a final touch and ready for other collaborators to accept your changes. So that is where your local changes should go to the remote changes. So that is where you just stage the changes. Then comes commit. Once you finish this staging of changes, you commit that. That means you are making the entire changes, one file, two file, or n number of files, and you are making a single commit. Before pushing, you want to make sure everything in your local computer has been committed and it has a comment which is called a commit message attached to that. Then push it. So basically upload your local commits to the remote repository, whether it's a GitHub or GitLab, doesn't matter. So once you do that, other collaborators, they start pulling your code to their local repository. So they get your changes, whatever change you have done, so they get it. How they get it? They do a pull. Yeah. Okay. So the moment they do a pull, they get your changes or any other testers or collaborators, they have done the changes. So they get that into their local machine. Now next one is how to clone a repository. A simple command, git clone, then the repository name. So this part is the command. This keeps changing depending on your repository. So this is called CLI, command line interface command. This has to go in a terminal prompt, whether you are using Ubuntu or macOS or Windows. This is what you can type and it will bring all the code bases and their files, repository, the artifacts, stuffs, everything into your local repository. This clone command does that. Okay. Next one is making changes and staging. What does that mean? You modified some files and you check the status that yes, it is modified. It will show what all files are modified. Then you stage your changes. Once you stage your changes, then status will not show anything as modified because you staged it. Okay. Now to do that, that is done in 2 steps. Status is just to show, this is not part of the step. These 2 commands, CLI commands, which is git add file name if you are doing a single file add, or git add dot if you are adding everything to the staging area. Okay. So the command is a single command basically. Git add is the command followed by a file name or a dot. File name means you are just dealing with one file. Dot means you are dealing all the files in that current directory. Committing changes. Again, this is a very simple command. Git commit is the command. Then -m is for message. Then you give your description of that commit. This is a free text. You give whatever you want here, but something meaningful always helps. So git commit followed by -m, then whatever changes you have done, let's say in the file you changed some kind of text. For example, the date was yesterday's, you made it today's date, so you put your message like date updated, something like that. Then comes pushing to remote repository. Once the changes are staged, committed, a message is attached, now you are ready to push it to the remote branch, okay, so that other people will start seeing your changes and taking those changes into their local machine. That is possible only when you push your changes. And master is your remote branch, and the command is git push, then origin, which signifies that it is in the remote, and this is the branch name. So if you don't push to master, push it to, let's say for example, my changes. So the command will be git push origin my changes, or for example xyz branch, it will be git push origin xyz branch here. That's how it works, okay. So that's pretty much everything in a nutshell. You, as a manual tester, you must know how to clone a repo, how to make some changes and stage it. Then third step is how to commit and attach a meaningful message, and fourth step is push it to a remote branch. It could be a master branch or main branch or your own custom branch, okay. If you like the video, give a thumbs up and don't forget to subscribe to the channel. Thank you very much for watching.